Hello and Assalamualaikum. I greet to Madam Nur Rashida and all my classmates. My name is Muhammad Rashid Miroslan. I am the first presenter and today we want to find the relationship between our study and exam score by using the least square method. So what is the relationship between our study and exam score? The relationships between these two things has been the main point of success in exams for students achieving good grades in their tests. So, we want to investigate whether the relationship between our study and exam score does really affect students' results or score in exam using the least square method. By using this method, we can identify the best fit line for a given collection of data. And by the using of the least square method approach, it is a type of mathematical regression analysis that shows the relationship between the data points visually. The table shown is the data set on our studied and exam score. So, before we want to solve this question, first, we need to know how to use the least square method. When we use the least square method, we can obtain the best fitting curve or best fit line for a set of data points by minimizing the sum of the squares of the offset or residual component of the points from the curve. When determining the correlation between two variables, the trend of the results is statistically calculated. We have the three types of least square method. The first one is a linear model. The second one is the quadratic model, and the third one is the cubic model. Okay, to solve this least square method using linear model equation, first we need to find the matrix. So we can declare the matrix. The first is M, C, and V. The M matrix is the our study, and then the C matrix is the exam score. And then the V matrix is the A, B. So, to answer this question, we need to find the normal equation. Therefore, to find the normal equation, the formula is the inverse of M transpose M multiplied by M transpose C, and the answer we will get is the matrix of 7529 over 109 for A and 1258 over 327 for B. Therefore, we can get the equation for linear model, which is y equal to 7529 over 109 plus 1258 over 327x. After finding the normal equation, we need to find the error vector and the magnitude. To find the error vector, we can use the formula E equal to C minus by MV. So, you will get the answer in matrix. Then, the answer for the magnitude error is 1023 over 109. From here, we can construct a linear graph using the least square method that we used earlier. So, this is the result of a graph of a linear model that we solved using least square method. From here, we can see the result of a scatter plot and the best fit line of a linear model.
For quadratic model, we have been given the data that generates a system of linear equation with the metric representation as below. From the M, we can see that in column 1 is variable 1, and in column 2 is x, and in column 3 is x squared. Now it's time to find the normal equation using equation V equals to M transpose M times M transpose C. Then we will get the least square solution. After that, we will find the best fit linear curve for the quadratic model. After getting the best fit for linear curve, we will find the error vector, which is E. Then after we find the error vector, we will find the magnitude for the error vector, which is 56979. divide by 7474. And from this slide we will see the graph that been made by the best fit linear curve for the quadratic model.
So next we have cubic model that is x power of 3. The data generates a system of linear equations with the metric representation as below. For the first column we have variable 1. And for the second column, we have variable x. For the third column, we have x or x squared. And for the fourth column, we have x power of 3. So we can find the system of linear equation by finding the v. After finding the least square solution, we find the best fit linear curve. After that, we find the error vector with the symbol of E. So next, as you can see, we have a graph of cubic model by value the slide before. So we have the graph 1 and graph 2. So the conclusion, based on the model above, the following error magnitudes in the approximations are obtained. For the linear, error magnitude is 9.3853211101. For the quadratic, 0.62362857 and for the cubic, 7.1917222077. The best fit curves in this case, which will give the best approximation, is the cubic best fit curve because it has minimum error in terms of its magnitude. As you can see, we have linear model graph, right corner. And that's all from me. Thanks for watching.